Hello everyone. In this video, we will learn how to convert Microsoft Word docx documents to JPEG images using the Cloudmersive Convert API in Python. This API returns exactly one JPEG image for every page in our Word document. We'll walk through a quick demonstration of this API in Google Colab, which is just a hosted Jupyter Notebooks environment. And we'll use complementary Python code examples from the Cloudmersive API console to construct our API call in just a few minutes. Before we begin, it's important to note that we'll need an API key to use Cloudmersive APIs. We can get a free API key by creating a free account on the Cloudmersive website, and that will give us 800 API calls per month with no commitments. Once we've created our API key, we'll find the API console tab in our management portal, and from there, we'll select the Convert API option. On the Convert API console page, we'll navigate down to the Convert Document path, and from there, we'll click on a tab that says Convert Word docx document to JPEG image array. We'll find some brief documentation here, along with the option to test a conversion without any code if we want. We'll want to pay close attention to the response model we see here, since we'll be referencing this to generate output JPEGs in our environment. At the bottom, we'll click on the Python Programming Language tab to bring up Python code examples. This code is ready to import the Convert API client and a custom API exceptions library. And below that, we'll notice the bulk of configuration, instantiation, and API response handling is already taken care of for us. To get started, we just need to click on the Install Python SDK dropdown, copy that command, along with the rest of our code, and paste all of this in our environment. As a quick note, we'll want to import the base64 library at this stage as well, since we'll need a method from that library to decode the file contents this API returns. Before we do anything else, we'll grab our pip command and run it to install the Convert API resources. Once installation is complete, we'll walk through 3 quick changes we're going to make to our code. First, we're going to replace placeholder text in the configuration snippet with our own API key string. Second, we're going to replace the input file placeholder with a file we upload on our local path. Third, we're going to replace the print line in our try except block with some code that actually generates the resulting JPEGs. That way, we can download and view our outputs right away. Since I'm working in Colab, my API key is stored in the Secrets tab. I'm going to replace this API key placeholder text in the configuration snippet with the userdata.get method that Colab provides. And I'm also going to add the import that goes along with this method to the top of my file. Next, I'm going to upload a multi-page Word document from my file system onto my local path. Once that's uploaded, I'm going to set the input file variable to the relative path of my file. Below this, we'll notice we have the option to control the output quality of our JPEGs using an integer variable. The lower this number is, the higher our compression will be, which means our file size will be smaller, but our quality will also be lower. I'm changing this number to 75, which is actually the recommended option. Finally, I'm going to replace the print statement in the try except block with some code of my own. The print statement is just printing the content of the API response object to my terminal, which doesn't interest me very much. I want to generate each JPEG from my response array as its own file on my local path, and I can do that easily. If we remember what we saw in the response model on the API console page, the bulk of our API response object is structured as an array of nested objects, each of which contains the output JPEG contents we need relative to the docx page they're representing. That means we can iterate through our API response to generate each new file, and we can name our files with the same page number that they came from. That'll keep us organized when we put output JPEGs in our environment. In my example code, I'll create a variable called newFile, and I'll set that to an empty string. Below, I'll create a for loop that iterates through the JPEG result page's object attribute of the API response object. We can point to this attribute directly using standard dot notation, and we can do the same with objects represented by I in each iteration of our loop. In the first line of my loop, I'll set my newFile variable equal to a string that starts with a creative name, like newFile, and that subsequently adds a string version of the page number attribute from the current object in this loop. Again, we're just referencing attributes directly like any object. I'll then add a JPEG extension string at the end. Below that, I'll use a with open statement to write binary to my newFile variable, and I'll then use the base64 decode method from the base64 library that I imported earlier to convert file content from the current object in this loop back to a binary string. Now I can cleanly write binary to my new file. To wrap it up, I'll close the current file in each loop. Now I'll run my code, and we'll wait a few seconds to make sure everything worked correctly. As we can see, I now have a few JPEG images on my local path named dynamically based on the docx page that they came from. This is a great way to turn docx files into lightweight, immutable images that can be used anywhere with only a few lines of code. And that's all there is to it. If you have any questions after following along with this video, please do not hesitate to reach out to a member of our team.